Today I will explain you about lens, terms related to lens, and we will mainly focus on drawing ray diagrams related to lens. We will mainly draw ray diagrams related to convex lens and related to concave lens to show the formation of images. At first, we will discuss some important points like what is a lens, what are the types of lens, terms related to lens. So, the first topic is what is a lens. If I ask you what is a lens is a transparent medium. This portion is a lens. A lens is a transparent medium bounded by two spherical surfaces. This surface is part of a sphere. This surface is also part of a sphere, bounded by two spherical surfaces. Here you can see this is a lens, and its two surfaces are the part of this sphere and the second surface of this sphere. So what is a lens? A lens is a transparent medium bounded by two spherical surfaces, or one surface is plane and other is spherical. One surface may be plane, other is spherical. Now if I ask you what are the different types of lens, the simple answer: convex lens and concave lens. But there are many other different types of lenses, like this one plano-convex lens, this one plano-concave lens, this one convexo-concave lens, this one concavo-convex lens. But in class 10 we will discuss mainly about two types of lens. One is convex lens, another is concave lens. Convex lens is a type of lens which is thick in the middle and thin at the edges. Concave lens is a type of lens which is thin in the middle and thick at the edges. So there are two main types of lens. This convex lens is more properly called biconvex lens. Both the surfaces are convex, thereby it is called biconvex. And this one is also called biconcave lens because both the surfaces are concave. Now, convex lens is also called converging lens. And concave lens is also called diverging lens. The reason is that if I allow a parallel beam of light, to pass through the lens, after refraction, the light rays converge at a point. Thereby convex lens is also called converging lens. But in case of concave lens, if I allow a parallel beam of light to pass through the lens, the light rays appear to diverge from a point. These light rays appear to diverge from a point. And thereby this one is diverging lens. So if I ask you what are the two types of lens, one is convex lens, another is concave lens. Convex lens is also called converging lens. Concave lens is also called diverging lens. And the third topic is terms related to lens. Some important terms which you should know before going to start the ray diagrams to show the formation of images. The important terms are: first one, center of curvature; second one, radius of curvature; third one, principal focus; fourth one, focal length; and the fifth one, optical center. I will discuss only these 5 terms because these 5 terms are very essential. You should know these terms to draw the ray diagrams. I am focusing mainly on ray diagrams then other important terms will also be discussed in detail in some other videos. So the first term is center of curvature. Now what is center of curvature? You can see here, this is convex lens. This surface is a part of a sphere and this is the center of the sphere. This surface, this one, is also part of a sphere and this is the center of the sphere. And this center of the sphere of which lens surface is a part. लेंस का सरफेस जिस स्फीयर का पार्ट है उसका सेंटर को हम लोग बोलेंगे सेंटर ऑफ कर्वेचर. सो एक लेंस में, बाई कॉन्वेक्स लेंस में, वी कैन सी देयर आर टू सेंटर ऑफ कर्वेचर्स दैट कैन बी डिनोटेड एज 2f1 and 2f2. Similarly, for this convex lens, more properly biconvex lens, you can see here this surface is a part of a sphere and this is the center and this is center of curvature. Similarly here, this is the center, so center of curvature. So how many center of curvatures are there for biconvex or biconcave lens? Or simply if I ask you convex and concave lens, there are two center of curvatures that can be denoted as 2f1 and 2f2. Similarly in convex lens we can use the symbol as 2f1 and 2f2. So if I ask you what is center of curvature, the center of the sphere of which lens surface is a part. Okay, now the second term is the radius of curvature. So radius of curvature is the radius of the sphere, is the radius of the sphere of which lens surface is a part. Okay, so ये sphere का ये center, तो ये radius, इस radius को हम लोग कहेंगे radius of curvature. Now the next term is principal focus. I already told you, if I allow a parallel beam of light, if I allow a parallel beam of light parallel to the principal axis, if I allow a parallel beam of light parallel to the principal axis to fall on this convex lens after reflection, these light rays always converge at a point on the principal axis, at a point on the principal axis, and this point is called principal focus. This is f2. Similarly, if I allow a parallel beam of light from this side, they will converge at a point. You can mark that point as f1. Okay, so if I ask you principal focus of convex lens, principal focus of convex lens is a point on the principal axis of a convex lens at which the light rays incident parallel to the principal axis, the light rays incident parallel to the principal axis converge after refraction through the lens. And in case of concave lens, if we allow a parallel beam of light parallel to the principal axis, if we allow a parallel beam of light parallel to the principal axis to pass through this concave lens, the light rays appear to diverge. The light rays appear to diverge from a point on the principal axis, and this particular point is principal focus. In case of concave lens, this point can be denoted as f1. Similarly, if I allow a parallel beam of light to fall from this side, which is parallel to the principal axis, the light rays will appear to diverge from a point, and this point can be considered as f2. So if I ask you how many center of curvatures are there for a convex lens or a concave lens, the answer is 2. Similarly, if I ask you how many principal foci are there, plural of focus is foci, how many principal foci are there for a convex lens and for a concave lens? 2 principal foci here, two principal foci can be labeled as F1, F2, here also F1, F2. So discuss three important terms. First one, center of curvature, second one, radius of curvature, third one, principal focus. Now if I ask you what is focal length, but before getting into that term, you should know what is optical center. Now this is convex lens, and if we allow a ray of light to pass through lens, we know that there is refraction, and when a ray of light passes through a lens, it suffers refraction two times. It suffers refraction two times on the two surfaces. But for convenience, we draw diagrams like this and we show direction change only once for convenience only, but actually the light ray suffers refraction two times. So what is optical center? Optical center is a point in a lens, through which if a ray of light passes, this is convex lens, through which if a ray of light passes, it passes undeviated. It passes undeviated or without changing direction. I can show you here for concave lens. This is concave lens, and this is central point. If a ray of light passes through the lens, it passes undeviated or without change in the direction. A slight lateral shift is there, but that is neglected. So if I ask you what is optical center, optical center is a point in a lens through which if a ray of light passes, it passes undeviated. इसका मतलब ये है कि ऑप्टिकल सेंटर से कोई भी लाइट रे पास होने से उनका लाइट रेज का डायरेक्शन चेंज नहीं होता. लाइट रेज पास straight without any change in direction or without any deviation. So ये point optical center और ये point optical center we can mark, or optical center can be denoted by symbol O. Now another term, focal length. The length of the line joining the optical center and focus. This length is called focal length. Both the sides we can see focal length. O to F1, O to F2, this length is focal length. So I discussed 5 important terms in total. First is center of curvature. If you look at this diagram, 2F1, 2F2 denotes center of curvature. Now radius of curvature. The radius of the sphere of which lens surface is a part is called radius of curvature. Principal focus, convex lens में वो point principal axis पे अगर हम लोग लाइट रेज पैरेलल टू द प्रिंसिपल एक्सिस लेते हैं तो आफ्टर रिफ्रैक्शन लाइट रेज ऑलवेज इसी पॉइंट से पास करेगा आफ्टर रिफ्रैक्शन ऑन द प्रिंसिपल एक्सिस. दिस पॉइंट इज कॉल्ड प्रिंसिपल फोकस. इस प्रिंसिपल फोकस ऑफ कॉन्वेक्स लेंस इज रियल बिकॉज लाइट रेज एक्चुअली कन्वर्ज हियर आफ्टर रिफ्रैक्शन. And in case of concave lens, if we allow a parallel beam of light parallel to the principal axis to pass through concave lens, the light rays after refraction appear to diverge from a point on the principal axis, and this point is called principal focus. And principal focus of concave lens is virtual because light rays do not actually intersect here. Light rays appear to diverge from this point after refraction. So we discussed important terms related to lenses that will help us in drawing ray diagrams for both the type of lenses, convex as well as concave lens. After discussing these 5 important terms, center of curvature, radius of curvature, principal focus, focal length, optical center, I should say to you that for drawing ray diagrams, the important things required: a scale, ruler, a beam compass, a pencil, eraser, sharpener. So this is the scale, ruler which you need. You need a beam compass, then you need pencil, you need eraser, and you also need a sharpener. So these are the required things. Be ready with these things because if you draw diagram properly now along with this that will help you in drawing the diagrams in future during examination also. Practice is required to draw the ray diagrams. In this part of video, I will discuss the rules or rays for the formation of images by convex lens. So what are the common rules that are followed for drawing the ray diagram to show the formation of images in case of convex lens? And the first rule is that if a ray of light incident parallel to the principal axis, if a ray of light incident parallel to the principal axis in case of convex lens, what will happen to this light ray? You know that in a lens there is a refraction happens, so the reflection is not taking place, so this light ray will pass to the other side. But what will happen to this light ray? This light ray after refraction will pass through focus, and after refraction it will pass through focus f2. Okay, so the first rule, if a ray of light incident parallel to the principal axis in case of convex lens, after refraction this light ray passes through focus f2. Now second rule is opposite to the first one. If I ask you, what happens to a ray of light that incident after passing through focus? If a ray of light incident on a convex lens after passing through focus, what happens to this light ray? After refraction, this light ray will become parallel to the principal axis. It will become parallel to the principal axis. And the third rule is simple one. If I ask you, what happens to a ray of light which passes through the optical center of a lens? If a ray of light passes through optical center of a lens, it passes undeviated or without changing direction. So these are the three important rules. First one, let me explain once again. A ray of light incident parallel to the principal axis in case of convex lens, after refraction the light ray passes through focus f2. If a ray of light incident after passing through focus f1 on a convex lens, after refraction this light ray will become parallel to the principal axis. And the third one, if a ray of light passes through optical center, it passes straight without any deviation. In this part, let me show you how to draw convex lens for ray diagrams and do the different labelings. For drawing the convex lens, at first you can do one thing. You can draw a straight line. You can draw a straight line 10 to 12 centimeter in length. I have drawn here around 13 centimeter length, and so center point is 6.5. so mark the center point 6.5, and then here this is around 4 centimeter. So this is the center point, and from the center point, whatever is the thickness of the lens required, I have to decide that, like up to here. From that point I can draw one part of the lens. Okay, so similarly for the same thickness I have to check the thickness like this. I can draw the second part of the lens. And we can mark these 2 points as center of curvature. These 2 points as center of curvature. You can do one thing. If you need a darker diagram, can draw like this. So this point is optical center. This is 2f2 and this is 2f1, and roughly half of that can be considered as f1 this side and f2 this side. Not that accurate measurement is required, but roughly you can mark the f1 and f2, these 2 points. So in this way you can draw the convex lens for different ray diagrams, and I suggest you to draw these type of diagrams, 6-7 diagrams. Be ready with such diagrams so that you can draw along with the video the different ray diagrams. Now you should divide this lens into 2 halves by drawing dotted line. This is for convenience. We know that when a ray of light passes through a lens, convex or concave, it suffers refraction 2 times. But in ray diagrams, for convenience, we change direction only once, and that too from the middle of the lens. So this separation, this midline, will help you to change the direction of the incoming incident rays. So I will change direction from this particular point and the ray of light passes through focus. So in this way you can draw convex lens and you can mark the different points. You should try to draw the thinner lens, not the thick one. Okay, and this measurement depends on you. If you are comfortable with 6 cm, 5 cm, the gap, it depends on you. Now to draw diagram related to concave lens, we should know how to draw this concave lens using compass. We can draw a straight line. Length I have taken it to be 14 cm and I have marked the center point 7 cm. Now it depends on you that length of the lens which you are going to take. So I am considering this to be 4 cm. Then this is the compass. The thickness of the lens depends on me this time. I have taken this much length. You can draw one part of the lens from this side and the other part from this side. Thickness should be equal, this part. Because we are drawing all the ray diagrams for biconvex and biconcave lens, so both the surfaces are equally convex and equally concave. Now we can join these 2 points here, these 2 points. These parts can be erased. And I have already told you that when a ray of light passes through a lens, it suffers refraction 2 times, but we are drawing this midline that helps us to change the direction only once. We'll change direction from this part and this line will help in that. You can draw it. The center point is optical center here, and this is center of curvature. That can be labeled as 2f1 and 2f2. Then the midpoint of optical center and f1 is roughly taken as first focus and second focus respectively. F2 we should write second focus. And when the ray of light passes when a ray of light passes through this lens, we have to change direction from this mid part, and the ray of light suffers refraction. Actually, it suffers refraction 2 times, but for convenience we change direction once. This side we should draw dotted line. Okay, now you can draw convex lens like this using pencil, scale, compass, eraser, etc. Now I am going to discuss first ray diagram for convex lens where object is placed at infinity. I will draw diagram in 2 different ways. In the first one, the incident rays are considered parallel to the principal axis, and here the incident rays are not considered parallel to principal axis, but they are parallel to each other. So for the first one, object is placed at infinity, so we can consider 2 light rays or more than 2 incident parallel to the principal axis. For the formation of an image, minimum 2 rays are required. So I am considering 2, and these are the incident ray. And according to the rule, these 2 light rays after refraction will pass through focus. As we discussed the rules, this one will also pass through focus. So if object is placed at infinity, image is formed at focus, and you can also draw an object at a large distance like this, and from that object you can show the incoming incident rays as shown. So this is the first diagram where object is placed at infinity, image is formed at focus, and here the incident rays are parallel to the principal axis. The second diagram where I will consider the incident rays, but the incident rays are not considered to be parallel to the principal axis. So a ray of light incident through optical center, we know according to the rule this light ray will pass straight without any deviation. And the second one we can consider like this: the 2 incident rays should be parallel to each other, and we change the direction from the middle of the lens. After refraction, according to the rule, this light ray will become parallel to the principal axis. So the refracted light rays after refraction, these light rays will meet at a point, and we can draw image as that point. So the image is formed at focus f2. If object is placed at infinity, image is formed at focus, so we can write here position of image at focus, and this is f2. Now if I ask you what is the nature of image, real and inverted. What about the size of image? Size of image is point like, or we can say highly diminished. Point like or highly diminished. So you can draw these diagrams. Both the methods are there, and the first one, incident rays are parallel to the principal axis. In the second one, incident rays are parallel to one another, but they are not parallel to the principal axis. Now we'll discuss second ray diagram where object is placed beyond 2f1, beyond center of curvature, or we can say between infinity and center of curvature. For that, object is placed beyond C. and from the top of the object, we will have to draw the incident ray. The incident ray, it is parallel to the principal axis. It is parallel to the principal axis, and according to the rule, this light ray will pass through focus. Then second one we can consider from optical center. If a ray of light passes through optical center, it passes straight without any deviation. So after reflection, the two light rays converge at a point between focus and center of curvature, and we can draw the image by drawing the perpendicular on principal axis like this. So if AB is the object, we can write A dash B dash is the image. Okay, and here position of image we can write between focus F2 and center of curvature 2F2. Nature of image, real and inverted, and size of image is smaller or diminished. If you want, you can draw the same diagram using different set of rules. Let us consider another way of drawing the diagram. This time I am considering a ray of light passes through optical center. It passes straight without any deviation. And second one I can consider from focus. If a ray of light incident after passing through focus, it becomes parallel to the principal axis, and you can see this time also the image is formed between focus and center of curvature, really inverted image. So AB is the object, A dash B dash is the image. So in the second diagram, object is placed beyond center of curvature, image is formed between focus and center of curvature, real and inverted, smaller and diminished. You can do labeling like this, AB and A dash B dash, this is optical center. While drawing ray diagrams, you should always consider marking of arrow marks properly, because they are very much important. Now the third point, where object is placed at center of curvature 2F1. If we place object at center of curvature, image is also formed at center of curvature. If you know this thing, it will be easier to you to draw the diagram. So here I am placing the object at center of curvature. Object is placed at center of curvature, and image is also formed at center of curvature. And if you mark a point at the same length and height as the object for image, it will be easier. It is very difficult to draw since accurate measurement is required. A ray of light incident parallel to the principal axis. According to the rule, we know that it passes through focus. And if a ray of light incident after passing through focus, I will draw that. Before that, I am doing one marking that will help me to draw the diagram properly. If a ray of light incident after passing through focus, then it becomes parallel to the principal axis. It becomes parallel to the principal axis. Arrow marks are very important. You can see here that image is formed exactly at center of curvature. So if AB is the object, A dash, B dash is the image, and in this diagram you can see the position of image. If it is asked, it is at center of curvature 2f2. Nature of image is real and inverted. Now about the size of image, it is equal to the size of object. So this is very important diagram where object is placed at center of curvature, image is also formed at center of curvature, size of the image, object is equal to the size of the image, and the image is real and inverted. Now we discuss point number 4 where object is placed between focus f1 and center of curvature 2f1. So if object is placed between focus and center of curvature, we'll see where the image is formed. Here between focus and center of curvature, anywhere in between you can place. It doesn't mean exactly at the middle point. A ray of light incident parallel to the principal axis. You know what happens if a ray of light incident parallel to the principal axis, after reflection this light ray passes through focus, and if a ray of light passes through focus and falls on the convex lens, if a ray of light passes through focus and falls on the convex lens, after reflection the light ray becomes parallel to the principal axis. It becomes parallel to the principal axis. So we have to extend this one so that intersection takes place. We have to extend principal axis also. So this is the point of intersection. From here we can draw the image on the principal axis. So object is placed between focus and center of curvature, and image is formed beyond center of curvature. Okay, so position of image here is beyond center of curvature to f2. Nature of image is real and inverted, and size of image is enlarged or magnified. Enlarged or magnified. Now the point number 5 where object is placed at focus f1. If object is placed at focus, we will have to see where the image is formed. I am taking the height of the object is 1.5 centimeter. It depends on you according to your convenience. So object is placed at focus. If object is placed at focus, for formation of image, a ray of light considered parallel to the principal axis. This is optical center. And if a ray of light incident parallel to the principal axis, after refraction this light ray passes through focus, and this one, another light ray, if we allow it to pass through optical center, it passes straight without any deviation. So the refracted light rays, they appear parallel to each other. They are supposed to meet at infinity. So if object is placed at focus, we can say that the image is formed at infinity or at infinite distance. Nature of image is real and inverted. And about the size of image, it will be magnified or enlarged. Magnified or enlarged. So we discussed point number 5, where object is placed at focus. If object is placed at focus, image is formed at infinity. Nature of the image real and inverted. Size of the image magnified or enlarged. Now point number 6, where object is placed between focus f1 and optical center. This is the optical center. An object is placed between focus and optical center. This is the object placed between focus and optical center. A ray of light considered parallel to the principal axis. If a ray of light incident parallel to the principal axis, we know according to the rule this light ray will pass through focus. And if a ray of light incident and passes through optical center, it passes straight without any deviation. It passes straight without any deviation. So if you see that these two refracted rays, they are diverging in nature, and if you produce them back, the light rays appear to diverge from a point. At this point B, this one, and here virtual, erect and magnified image of the object is formed. Okay, virtual, erect and magnified image is formed. So if I ask you what is the position of the image, position of the image is on the same side as the object. Then what is the nature of the image? Nature of the image is virtual and erect. What about the size of the image? Size of the image is, we can say, highly magnified. And because of this property of convex lens is used as magnifying glass, because if object is placed between focus and optical center, a highly magnified virtual image is formed. Now we'll discuss 3 important rules or rays for the formation of image by concave lens. So as you can see, I have already drawn concave lens with principal axis and different marking. The center point here is optical center. So first rule, if a ray of light incident parallel to the principal axis in case of convex lens. If a ray of light incident parallel to the principal axis in case of convex lens, after reflection, this light ray appears to diverge from focus. This light ray appears to diverge from focus. So this part you should draw a dotted line, then you can extend. So here, convex lens, if a ray of light incident parallel to the principal axis after refraction, this light ray appears to diverge from focus f1. Now second rule, if a ray of light passes through optical center, it passes straight without any deviation. This simple one. And the third one, where a ray of light appears to converge at focus. A ray of light is coming towards focus, and this ray of light, it appears to converge at focus, but after passing through the lens, this light ray will become parallel to the principal axis. This light ray becomes parallel to the principal axis. So we discussed three important rules for concave lens. First one, a ray of light incident parallel to the principal axis in case of concave lens. After refraction appears to diverge from focus f1. A ray of light passing through optical center passes straight without any deviation. And a ray of light which appears to converge at f2 becomes parallel to the principal axis after refraction. These rules are important for drawing ray diagram to show the formation of images. In this way, we can draw concave lens using pencil, scale, compass, eraser, etc. Now I'll discuss first ray diagram for concave lens showing the formation of image. And the first point, where object is placed at infinity, that means object is placed at a large distance from the lens. In this case, if object is placed at a large distance, we can consider the incident light ray is parallel to the principal axis in one case. In the first case, we are considering that the incident light rays are parallel to the principal axis. You know that for the formation of image, minimum 2 rays are required. 2 rules you can follow, or same rules can be repeated. These 2 light rays, after refraction, they appear to diverge from focus. They appear to diverge from focus. This one appears to diverge from focus f1. So if object is placed at infinity, image is formed at focus. And in the first diagram, the incident rays are parallel to the principal axis. I am giving you another option, but you can follow this one also. In this second method, the incident rays are parallel to one another, but they are not parallel to the principal axis. We can consider one ray which is passing through optical center. It's passing through optical center. If a ray of light passes through optical center, it passes straight without any deviation. And second light ray, we consider that light ray appears to converge at focus. This light ray appears to converge at focus. But we know, according to the rule, this light ray which appears to converge at focus cannot reach focus. It will become parallel to the principal axis. We are showing the convergence at focus f2. But after refraction, this light ray will become parallel to the principal axis. So after refraction, the light ray becomes parallel to the principal axis. And if we produce this refracted light ray back, a virtual image is obtained at focus. a virtual image is obtained at focus. So this one a bit easier, and in the second one the incident rays are not parallel to the principal axis. So if I ask you, in this case, if object is placed at infinity, what is the position of image? Image is formed at focus f1. Nature of image is virtual and erect. And about the size of image is point-like, or we can say highly diminished. Point-like or highly diminished. Now we are going to discuss point number 2 for concave lens, where object is placed in front of the lens anywhere in between infinity and optical center. So I am placing an object between in front of the lens. I am placing between focus and center of curvature, but you can place anywhere in front of the lens. This is the object placed in front of the lens. A ray of light incident parallel to the principal axis from the top of the object. And we know, according to the rule, what will happen to this light ray? This light ray appears to diverge from focus. It appears to diverge from focus. So we'll have to draw it properly. It appears to diverge from focus. And a ray of light that passes through optical center, it passes straight from the top of the object. A ray of light passing through optical center, it passes straight without any deviation. And these two refracted light rays appear to diverge from this point. So if this is A, this will be the image of A, we can consider A dash. If this is B, and if we draw the perpendicular here, virtual image, so dotted line. So A dash, B dash will represent the image of AB. So AB is the object, A dash, B dash is the image, is the virtual erect image is formed here. So if I ask you what is the position of image, position of image is between f1 and optical center. Between f1 and optical center. If I ask you what is the nature of the image, nature of the image is virtual and erect. What about the size of the image? The size of the image is always smaller or diminished. So in these 2 points, the 2 diagrams for concave lens, we have seen that a concave lens always produces virtual, erect and diminished image of an object placed in front of it.